is Ana Romero, and this is a video assignment for my chemistry class, in which I will be discussing the chemical bondings and different types and other concepts of the periodic table. Hope you like it. So what is a chemical bonding? On the left, we have a hydrogen atom, and to the right, we have a chlorine atom. When these two atoms combine, they form a chlorine acid. There is a force that maintains the atoms together. A chemical bonding is the combination of forces that holds together atoms, ions, and molecules when forming different stable groupings. In order to understand better chemical bondings, it is important to know certain concepts. The first one is the octet rule. In order to have better stability, atoms occupy their most external energy levels with 8 electrons. This way, it simulates the electrical configuration of a noble gas. There is an exception, and it is that hydrogen doesn't go up to 8 electrons, but it imitates the configuration of helium going up to 2 electrons. So for example, if we have two elements, one with 7 electrons in its maximum energy level, and another one with only 1 in its maximum energy level, these two elements won't be stable. In order to be stable, one element has to share with the other 1 electron in order to have 8 electrons each one and meet the octet rule. This happens every time elements want to bond. Another concept is the Lewis structure. A sodium atom has 2 electrons in its first energy level and 8 electrons in its second energy level, and 1 electron in its maximum energy level. That, or those electrons from the highest energy level, are called valence electrons. So, if you want to represent the valence electrons from one element, we will use the Lewis structure in the following way. We write down the symbol of the element and represent with a dot that valence electron. Those valence electrons are called Lewis structure. If we represent calcium with 2 dots, it means that it has 2 valence electrons. Carbon with 4 valence electrons. Aluminium with 3, or any other element from the periodic table. The next concept that we're going to review in this video are the different types of bondings. Bondings are classified as ionic, when there is a loss or intake of electrons, and covalent, where there are electrons being shared. Let's take a look at the ionic bonding. This type of bonding occurs when there is a loss or intake of electrons, when the difference of electronegativity is greater or equal to 1.7, and when there is a combination between metals and non-metals. Let's take a look at this example right now. Let's outline the formation of the chemical bonding between sodium and chlorine. Sodium has 1 valence electron and chlorine has 7 valence electrons. Chlorine has an electronegativity of 3.0 and sodium of 0.9. So if we look at the difference between these elements, we subtract the values and get 2.1. It is likely that this is an ionic bonding since it is greater than 1.7. Also, the atoms used for this example are sodium, a metal, and chlorine, a non-metal. The formation of this bonding will be the most electronegative element, chlorine, which will gain electrons in order to meet the octet rule, meaning that it will have 8 electrons. Sodium, being the most electronegative element, will lose its electrons. Since chlorine is left out with an extra electron, it turns into a negative ion. Sodium becomes positive since it loses 1. Negative ions are called anions, and positive ions are called cations. The next type of bonding that we're going to talk about is covalent bonding. It occurs when there are electrons being shared, when two or more atoms share electrons to form the bond, and when there is a difference of electronegativity less than 1.7, and when there is a combination of nonmetals. We know that oxygen is a nonmetal, so here we have the oxygen. Every oxygen has 6 valence electrons. Each one needs 2 valence electrons to meet the octet rule. Since they have similar electronegativity and the difference is 0, meaning less than 1.7, the bonding is covalent and they will have to share electrons to meet the octet rule. In this case, they have to share 2 electrons, so each one is left with 8 electrons. Next, we're going to show how we add up the dots so they can be shared. Once the electrons are being shared, the oxygen from the right will have 8 electrons and the oxygen from the left will also meet the octet rule. Another concept that I forgot to mention before jumping into the type of bondings is electronegativity. It is the atom's ability to attract electrons. In the groups of the periodic table, it increases while going up. The higher the element, the greater the electronegativity it will have. In the period, it increases going right, making fluor the most electronegative element with a value of 4.0, and Fr in the right, to the left, being the least negative with a value of 0.7. Thank you so much for watching my video. I hope it was clear, and a big shout out to Professor Dwayne for letting me submit this assignment. Thank you.